Hey, how are you? In this video, we are going to solve the Leetcode daily question, and the question is count symmetric integers. In this question, we are given an input which is low and high. These are two integers which are given as an input. For example, 1 and 100 or 1200 and 1230. What this input is saying is you have a range, for example 1 to 100 or 1200 to 1230, and you need to find out how many symmetric integers do you have in this particular range. For example, in the example number 1 where the input is 1 to 100, the output is 9. When it is 1200 to 1230, the output is 4. It means we have 9 symmetric integers in this range 1 to 100, and we have 4 symmetric integers in this range 1200 to 1230. 11, 22, 33, 44, 55, 66, 77, 88, 99. These are the symmetric integers for first range 1 to 100, and in example number 2, 1200 to 1230, the symmetric integers are 1203, 1212, 1221 and 1230 itself. So yes, the range itself is also included. So 1200 and 1230 is also included. Now what are symmetric integers? Let me show you with an example. So let us consider this number 1212, right? So 1212 is an example. You have to break this into two parts, two equal parts, right? So we broken it into two equal parts. First part is 1 2, second part is 1 2. Now what is the sum of digits in the first part? 1 plus 2, which is 3, and for the second part it is 1 plus 2, which is 3. Now 3 and 3 are same, right? So if they are same, then we can say that this is a symmetric integer. And when we say it is same, we can also say it like if the sum in the left part is 3 and the sum in the right part is 3, the difference is 0, right? So if we don't have a difference in the sum of the left part and in the right part, then it is a symmetric integer. Now there is one very important note as well in this particular problem, that any integer which has an odd length cannot be symmetric. For example, if you have a range from 1 to 1000, then there is an integer 743, right? Now you might say that this is symmetric, but this is not. How can you say it is symmetric? If you break it into two parts, 7 and 43. For the first part, 7 is going to be your sum. For the second part, it is 43. So you can say 4 plus 3, which is 7. So 7 and 7 doesn't have any difference, but this is not symmetric, because remember I told you that you have to break this number into two equal parts. So right now if you break it into 7 and 43, or you try to break it into 74 and 3, both are not valid because these are not equal parts. This has one digit, the second part has two digits. So if it is an integer of odd length, you cannot break it into two parts which are equal, and that is why any integer which is of odd length cannot be symmetric. Now this question is marked as easy, and honestly, according to the constraint is the maximum number you are going to get is 10 to the power 4. So for this we can just run a brute force algorithm to solve this particular question, and this will be solved, and that is why it is marked as easy. So let me show you what is the easy solution for this problem. What you can do is you can just run a loop from low to high, right? For example, if the low is 1200 and the high is 1230, so you can run a loop from 1200 to 1230, and for each of the number you can perform an operation, and this operation can tell you that this is a symmetric number or not. And if it is symmetric, you can just increase your count. For example, if the number is 1203, you can make it as a string, right? You can convert your number as a string, and then you can find what is the length of my number. If the length of your number is even, that is, for example, the length is 4 right now, so it is even. So we can break it into two parts of two equal parts, length of 2 and length of 2. The first part is 12, second part is 03. What you can do is you can convert both the part into a list, and you can change each digit as an integer. So first 12 is going to become 1, 2, 03 will become 0, 3. And then you can take the sum of both the parts, and it will be 3 and 3. And since 3 and 3 are same, or you can say 3 minus 3 has a difference of 0. If the difference is 0, then the sum is going to be same, and we can say count plus 1. And if the difference is not 0, that is, for example, 1217 is within this range, two parts are 1 and 2 and 1 and 7, right? 1 and 7, and you can say the first part is 1, 2, second part is 1, 7. The sum of first part is 3, the sum of second part is 8. 3 and 8 have a difference of minus 5. So you can say this is not a symmetric number, and you are not going to count 1217. So this is one of the algorithm, and this is one of the easy way to solve this particular problem. And let me show you how can you code this in Python. So right now this is the code which is for this algorithm, and this is the complete code. And you can see for this code I'm getting a runtime of around 68%, memory of around 96%. So memory is really good, runtime is good as well. And the solution is you have a count c equal to 0, then you run a loop from low to high, convert your number to a string, find what is the length of your number, and see if the length is even or not. If the length is even, then you can break your number into two parts, num1 and num2, and then you can map each character of your number into integer and take the sum. Do it for num1 and num2. So this is for num1, this is for number 2, and then you can see if they are equal, you can take the count as count plus 1, and after you come out of this loop, you can just return the value of your count, and that is going to be your solution for this particular problem. Now this is a good solution for this problem, and it has a complexity of O of high minus low. That's the loop you are running, and digit length. Digit length because you are taking the sum of your digits, right? So the maximum digit is of 4 length, so this is going to be 4, right? Now this is fine for a small constraint, and in this question the constraint is that the maximum number is going to be 10 to the power 4. So this solution is fine. But if you want to solve this using another algorithm which is pretty efficient as compared to this, then you can continue watching this video, because I am going to tell another algorithm which is digit DP, and this is a pretty efficient algorithm to solve this problem. And if your question is marked as medium, or if your question is marked as hard, then this is the algorithm which you need to make, because then your constraints are going to be high. So what you do in this algorithm is, you don't try to find out from low to high. What you do is, you find out how many symmetric integers do you have till high starting from 1, and how many symmetric integers do you have till low minus 1 starting from 1 itself. You can understand this with this particular diagram, that if you want to find out from 1200 to 1230, so you need to find out all the symmetric integers within this range. So for that, if you can find from 1 to 1230, and then from 1 to 1199, which is 1 less than your low, that is the starting range, then their difference is going to be how many symmetric integers you have from low to high, right? This is going to be your range. So you just need to find out till high and till low minus 1, take their difference, and that is going to be your output. The time complexity of this is going to be O of high, and this is pretty efficient as compared to what we had previously. Now in this algorithm, what you do is, first find your range. Okay, my range is 1230. It means I have to go from 1 to 1230 and find out all the symmetric integers. You can convert your number to a list, right? Now this is a list of 4 numbers, 1, 2, 3, 0. Take a memory as well. This is a map, or you can say a dictionary. And since we are using DP, dynamic programming, this memory is going to store all the sub-problem solutions, because in dynamic programming we break our complete problem into sub-problems, and then we store its result, so that we don't need to solve the same problem again. Whatever the length of our number is, so right now it is 4, right? So we take a string which is starting from 0, 0, 0, 0, right? This is going to be our initial string, and then we are going to find out what is the next number. So the next number after this is 0, 0, 0, 1, then 0, 0, 0, 2, and then we are going till 1, 2, 3, 0. Okay, we will not go outside of our range, because we have a range and we need to find out within that range. Every time we create a number, right? When I say create a number, it means we are not running a loop from 1 to 1, 2, 3, 0. We are actually trying to create all the numbers which are possible in this range. Okay, and every time we create this number, we are going to store what is the difference at this point. It's 0, minus 1, minus 2. How? See, if this is your number, then you break it into two parts. The sum in the first part is 0. The sum in the second part is 0. 0 minus 0 is 0. So the difference is 0. Let us try to understand this with few examples. So if you generate a number which is 1217, in this case, we can break it into two parts. The sum in the first part is 3. The sum in the second part is 8. 1 plus 2 and 1 plus 7. 3 minus 8 is minus 5. And that is why this is not valid. This is wrong. I mean, we don't need to count it. If the difference is not 0, we will not count it. Now we have one more case, that even if the difference is 0, we are not going to count it. And the reason is, let's say we create a number which is 0, 3, 1, 2. So when the number is starting from 0 and it is 3, 1, 2, so the actual number is 312, right? And the length of this 312 is 3 and not 4, right? So we are also going to track what are the leading zeros in this particular number we generate. So the length we are expecting is 4. That's the length coming from the range itself. So we are saying all the numbers are 4 length. But if they have a leading 0, that is they are starting from a 0, then we are going to reduce how many zeros it has in the start. So 4 minus 1 is equal to 3. So the actual length of our number is 3. So we are not going to count it, even though the difference is 0. Let us take another example, 1201. In this one, the first part is 1, 2. The second part is 0, 1. 1, 2 will be 3, 1 plus 2, and 0, 1 will be 1, 0 plus 1. The difference is 2, right? And that is why we are not going to count it. But in case of 1203, we are going to count it, plus 1. So we just need to generate all the numbers and track what are the differences at each point. And then for each valid numbers, valid means for each even length numbers, we are going to increase our count. Now what's the logic behind generating all the numbers? Let us try to understand that. So this is our range, right? Up to 1230 we can go and we can find out all the numbers and try to see if they are symmetric or not. So what we can do is, we can start from 0000, right? Now for each of the digits, or we can say each of the indexes, we need to check what is the possible range we have. Now what are the different numbers we can put for this particular place? So we can say the original number is at this place is 1, right? So I can just say it can be 0 or it can be 1. It can never be 2, because if we are starting from 2, so after starting from 2, if we take the least number which is 000, 2000, this is out of our range. And that is why for each of the digit we have a range. For the first one, it is going to be 0 and 1, because the original number at this particular index or this particular digit is 1. So 0 and 1 is possible for this particular index. What about this index? Original number is 2, so we can go from 0, 1 and 2. For 3, or we can say for this particular index, we have 0, 1, 2 and 3, right? So this is our range. And for the last one, the number itself is 0, so we can go till 0. So now we have a range, right? Once we have a range, for each of the index, we are going to run a loop from 0 to 1 for this index, and for this index from 0 to 1 to 2, for this index 0 1 2 3, and for this index 0. So these are the loops we need to run, and in every loop we will get a new number. If we take this index, that is the first index, or we can say 0th index, and take the first number, which is 0. So now the first number is fixed as 0. Now here is the interesting fact you need to know. When the first number is set as 0 and the maximum range for this particular number or this particular digit is 1, and we are taking it as 0 for now. So anytime at a particular index when you fix a number, for example we are fixing 0 for now, and if this number is less than the most allowed digit, that is 1 for this particular index, then in that case the other indexes, the later indexes, will have 0 to 9 limit. I will tell you why. For this particular index we have 0 and 1 allowed, right? If we take it as 0, that is we put it as 0, in this case we are not bounded, we are not tightly bounded till 0 1 2 or 0 1 2 3 or 0. We can go till 9, because if you put the first index as 0, the other numbers can be till 9 9 9 9, because this number itself is within the range, right? 999 is less than 1230, and that is the important logic which you need to understand. If at a particular index you are taking a number which is less than the most allowed number, that is 1 or 2 or 3 or 0, then in that case the other numbers after it are going to have a range from 0 to 9, because the numbers which are generated will always be within our range. Now let's say we are taking it as 1, because at this index we will run a loop from 0 to 1, right? So 0 we have seen. What about if it is 1? So if it is 1, that is the maximum digit allowed for this particular index, then the next index will have a tight boundation that you cannot go from 0 to 9, because if we start from 1, right, and if we take the next number as 9 and next number as 0 0, then also this is going to be outside of our range. So if the number we are taking is maximum allowed for a particular index, then the next index is going to have a limitation or a tight boundation. So now this will have a tight boundation. It will go from 0, 1 and 2. Now let's say we are taking the first number as 1, the second number is 1. Then what is going to be the range for these two numbers? This is going to be from 0 to 9 and 0 to 9. And the reason is, for this index, the maximum allowed is 2, right? And right now we are taking it as 1, which is less than the maximum allowed. So in that case, the range is going to be from 0 to 9 and 0 to 9, right? Let's take an example. If we are taking the first two numbers as 1 and 1, then the next two numbers can be till 99, and this is still going to be less than our range. 1199 is less than the 1230 range. And that is how we are going to generate all the numbers, okay? So let us see how we can generate all the numbers. Let us try to understand this using this example. How can we generate the number 1203? We are starting from 0000, right? Now we will run a loop at this index, and the range for this index is 0 and 1, right? From 0 to 1, because the number itself is 1. So when we will reach to the loop where the value is 1, so we set the number as 1, and the remaining are going to have 000, the original numbers. Now we have got a new number which is 1000, right? We are also going to store what is the difference at this point. So the first two numbers are 1, because 1 plus 0 is 1. The second two numbers are 0, 1 minus 0 is 1, right? So for this number, the difference is going to be 1. Then we will run a loop for the next index, and since this is the maximum number allowed at this index, this will have a tight boundation from 0 to 2, right? Because 2 is the maximum allowed for this index. So we can take 1 at this place and then 2 at this place. Similarly, when this is 2, the next index is also going to have a boundation 0 to 3, because 3 is the maximum number. So 1, 2 and 0. We take 1, 2, 0, and this 0 is coming from the original 0. So when the number is 1, 2, 0, 0, the difference is 3. First two numbers 1 plus 2, second two numbers 0 plus 0. 3 minus 0, this is 3, right? So we generated a number which is 1200, and this time the difference is 3. But at this point, this particular index will have a range from 0 to 9, and that's because the previous range or the previous index is 0. It is allowed till 3, right? And since 0 is less than 3, we can go from 0 to 9, and we will select 3. And the moment we select it as 3, we can say 1203 is our number, and this time the difference is going to be 0. Now let us take an example where we are generating a number 0743, okay? Now this is just an example. So in this case, the difference is going to be 0 plus 7, and this is going to be 4 plus 3. This is 7, this is 7, the difference is 0. But still we are not going to count it. And the reason is, the length of this is 4, but it has a leading 0. 1 0 it has, right, in the start. So the length will be 4 minus 1, which is 3. And this length is odd. And since the length is odd, we are not going to count it. So that is the complete explanation of this particular algorithm, which is called as digit DP. Now how can you implement it? Let me show you the code itself, and I will explain you the code, okay? So this is the complete code for this particular algorithm. See, what we are doing is, we are just returning count of high minus count of low minus 1, okay? And now let me show you how this count function is implemented. We have a count function which is taking a number, right? Then we are converting our number to a list of integers. That's the first part. And then this is the memory we are going to store. We are going to store all the result, right? So that we don't need to perform the same operation again. Now there is an index. This index is telling us at which particular digit are we for our current range. then this tight is a boolean which is telling us that are we tightly bound. Tightly bound means do we have a boundation from 0 to the current number or 0 to 9 for the current digit. What is the difference at this point? Do we have a leading 0? And if we have, how many leading 0 are we having? So these are the 5 input we need to give to the function dp, and then we are going to run this dp function. We also say dp as dynamic programming. Okay. First of all, you need to check if I is equal to the length of the digits. It means you have reached to the end, and now you can just return. So we are going to return 1, or we are going to return true only if the length of my digits minus the leading 0, that is the length of our actual number, mod 2 is equal to 0. That is the length of our number is even and the difference is 0. In this case, we are going to return true, otherwise we are going to return false. Then we are going to store the key as well. The key will have all the input which we have in the dp function, and if the key is already in the memory, we don't need to do the computation. We can directly return the value of memo out of the key. So this is the memory we have. Now how many total symmetric integers we have got? That's the count of this. So this is the total we have, which is initially 0, and now we can select what is the range for this current index. That will be equal to digits of I, that is the current number, if we have a tight boundation, else it is going to be 9. So we can go from 0 to 9 if the maximum digit doesn't have a tight boundation, right? And now we are going to run a loop from 0 to the maximum digit which is allowed for this index. Then calculate the new tight, that is, do we need to have the tight boundation for the next index or not? So we will have a tight boundation only if we currently have a tight boundation and the current digit is the maximum digit which is allowed for this index. So if the current digit is the maximum digit, we have a tight boundation, and then the new tight will be true. Do we have a leading 0? We will have a leading 0 if we already have a leading 0 and the current number is 0. And what is the new count of the leading 0? It is leading 0 count which we already have plus is leading. It means we have a leading 0 again. It means that we can count it. So this will be true, and when the calculation will happen, this will be replaced with 1. What is the length of my number? So it is equal to the length of the digits minus what is the new 0 count. So all the zeros in the initial part will be removed, and this is going to be the length of our number. And then we are going to calculate what's my current position. For example, if the number is 0099, the I may be at index number 4 and we have two leading zeros. So the position is going to be 4 minus 2, that is going to be 2, right? So 0099 has a first number at 9, which is index number 2. So that's the position here. Now we are going to check if the length is even, and if the length is even and we do not have a leading 0, then we are going to calculate half of the length. And if the position is less than half, it means we are on the left side. Then we are again going to run the dp function with the next index I plus 1, the new tight value, and now the difference is difference plus d, right? This d is our current number, right? We are also going to pass if we have a leading 0 or not, and what is our new leading 0 count. And if the position is not less than the half, it means it is in the right hand side. So what we can say, everything will be same. We can just say difference minus d. Okay. So from here we are calculating the difference at each point, and there is one more condition else here, which is like if you do not have a length which is even, then in that case we are not going to change the difference value. We are just going to run the loop for the next index I plus 1. Okay. And after we come out of this loop, we are going to update our memory value, which is memory of key is equal to total. So how many total have we got? That's something we are going to just add it up here, and then we are going to return this total. And we are going to call this dp function with 0 and true. That means the value of I is 0. It means we are starting from the 0th index, and tight will be true. So initially the value of tight, that means we have a tight boundation, is going to be true. And that is the complete code for this particular problem. So let me scroll and show you this code again. You can pause and get the code. But I would say you can get the code, but the more important part is to understand the code. And to understand the code, you need to understand this algorithm, digit dp algorithm. So I hope you got the understanding of this algorithm. But if you have some doubt, then make sure that you try to re-watch that part of the video. And still if you have some doubt, then make sure that you put it as a comment, and I will reply to that comment to make sure that your doubts are cleared. And this particular submission is having a runtime of 97%, which is really awesome. Memory, you can see we are utilizing a lot of memory, but the runtime is good, right? So that's it for this video, guys. If you like this video, then make sure that you hit that like button, and if you have not subscribed to my channel as of now, then make sure that you hit that subscribe button as well. And I will see you guys in the next video. Thank you for watching this video, guys.